Can you turn your mic on, Ms. Grant? Thanks.
I had asked about Dr. Beamish's work, and you were giving some background on marine impacts.
So I had finished up the last pre-lunch session by describing why quantitatively the variables we've been using haven't been effective to date due to the complexity of the marine survival issues for Fraser sockeye and how complex their migration is from the freshwater to the marine environment, and why for some salmonids who remain more close off the coast of coast of Vancouver Island, for example, and remain local, using single environmental variables is a lot easier because you know where they are, they remain in a fixed area, and they don't have as broad migration. So that was from the quantitative perspective, why perhaps these single variables that we've been trying to use quantitatively haven't been helping us too much in regards to improving the forecast. So in light of that, starting in 2009, and we'd been thinking about this for a while, particularly through engagement with scientists in the US and other scientists working on salmonids that use the Pacific Ocean as a rearing ground for their juvenile stages. We'd been looking at this kind of red light, green light report card for qualitatively looking at environmental indicators for Fraser sockeye, similar to what they do in the US for some Chinook and coho stocks in the US that migrate out of the Columbia. They have some good red light, green light indicators for their stocks that have been somewhat effective in their forecasting approach. So we were deciding that if these single variable quantitative variables weren't going to work, we were going to go in this more qualitative realm. And this will lead into your specific questions. This is a table 5 in the 2009 Science Advisory Report of the report card that we produced for some key environmental indices that we thought would influence Fraser sockeye, particularly in the marine environment. Every year, DFO has annual State of the Ocean meetings, and they produce a research document out of that. I believe it's a research document, not a science advisory report, although I could be wrong. But it's a pretty thick document where they invite scientists and people and biologists and oceanographers working on environmental indicators in the ocean environment to these meetings every year. And this includes scientists from both within the department and outside of the department. And it's a very good document for summarizing ocean conditions within the Strait of Georgia and North Pacific, conditions that our animals will be experiencing, whether it's Fraser sockeye or Chinook coho stocks from the west coast of Vancouver Island. So this table is our attempt at synthesizing and integrating some of the key indicators that we think would influence Fraser sockeye in a broader perspective than a single environmental variable. And we were using this in addition to comparing performance with single quantitative variables to help describe the state of the ocean in a particular ocean entry year. So this table is organized with on the top line, there's ocean entry year is highlighted. So that's the year, generally it's thought, the main hypothesis in regards to marine survival is that it's early ocean survival that influences the marine survival component of Fraser or of animals when they enter the ocean. It's that early first part of their life history that's most important for influencing total mortality in the marine environment. So we're focusing in on the ocean entry year, which is two years after their brood year. So 2 years after the parents spawn, the eggs are deposited in the gravel. They come out of the gravel, spend a year in freshwater, and then migrate to the ocean. These would be the conditions experienced by fish stocks. And we've done a lot of work over the years, liaising with this State of the Ocean group that pulls together all these environmental indicators from Canada and the US scientists that pull these ocean indicators together to help explain some of the Fraser sockeye forecasts. And within that, you'll have different scientists' own forecasts. When I was describing earlier the usefulness of our particular forecasts, those in conjunction with other scientists' forecasts all are different hypotheses or different ways of exploring what factors are controlling or influencing Fraser sockeye survival. And in the state of the ocean, it's the factors particularly focused on the marine environment.
Perhaps you can help on Table 5. It says for 2009 returns, most sockeye, each 4 spawned in 2005. So you're talking about all of the stocks, the 19 stocks.
That's right. It's a summary for most sockeye.
Okay.
And given the larger age 4, since most sockeye are 4-year-olds, in 2009, most of the sockeye would have come from spawners in 2005.
But you're talking about all the 19 stocks.
That's right.
And it
In
says-
general.
In general. Okay.
Yeah.
And it says, and migrated to the ocean in 2007. You're talking about all of the sockeye stocks, the 19 stocks in general.
In general, yes.
So what I'm trying to understand is that these indices or conditions that you're talking about, you're assuming that they would have impacted all of the stocks in the same way? Because the results, you explained this morning just before the new break, that there are different results for the different stocks in terms of the return of the 4-year-old sockeye. So, but you're assuming here that all of these conditions would impact in the very same way.
Yes. I think this is just a tool to holistically describe if there's something extreme going on or if we're in a transitional period. It's more of a broader indicator, understanding that there'll be nuances within the stocks. There'd be no way to tease apart an individual report card necessarily for all the individual stocks. And again, this is just focused on the marine environment, so each stock will have unique environmental conditions in the freshwater environment as well. So the freshwater will also be driving.
Okay, so they...
Okay.
I hope I get this right with you.
Okay.
So in 2007, when they migrate to the ocean, the stocks that came from the 2009 brood are out there with the stocks that are going to be coming back in 2010. Is that correct? There'll be 3 years as opposed to the 4 years from 2009?
Yes, there would be mingling amongst the different
Okay.
years.
So the conditions that you're considering would be impacting, I'm just asking, the 2009 as well as the 2010 returns.
That's correct.
Okay.
Yes. So for the case of the one that you were referring to, 2007, that led to 2009 returns, this table, as you reiterated, really saying that for most sockeye are 4-year-olds, most of them who returned in 2009 hit the ocean in 2010, but you're correct that in 2010, some of the 5-year-olds from this same ocean entry period from 2007 would have experienced the same environmental conditions. And then that links back to your earlier questions about age proportions. And when I was describing how 5-year-olds, I applied a similar mortality productivity rate to the 5-year-olds in 2010 as those experienced by 4-year-olds in 2009. It's for that exact reason that you just asked your question, in that they all experienced the same ocean conditions. They entered the ocean the same time. The 5-year-olds who returned in 2010 would have also hit the ocean in 2007, similar to the 4-year-olds that returned in 2009.
Right.
So they're out there at the same time.
So if there was an extreme condition, marine condition, that would have impacted the 2007 sockeye, is it not fair to assume that would have impacted the 2010 run as well?
It would impact the 5-year-old component. So for that, and we did take that into consideration. Okay. So yes, you're absolutely right that what happened in 2007, independent of this graph even, because this graph is not explaining what actually happened in 2007 because we saw really poor productivity, but that poor productivity experienced by the 4-year-olds that returned in 2009 is the same environmental conditions in the marine environment that the 5-year-olds in 2010 would have encountered. Okay. And they comprise a much smaller component of the total, but they still would have been influenced, which is why we took that into consideration. So with this table, we were trying to qualitatively describe some of the key environmental variables that include some of the larger ocean indices. Some of you might have heard of things like the PDO, which is the Pacific Decadal Oscillation, which is a broad indices for the North Pacific, basically describing sea surface temperature anomalies in the North Pacific. And if it's a warmer PDO, it's generally assumed that it's poorer conditions for salmon and Fraser sockeye. Then there's a bunch of physical conditions that are more specific, localized sea surface temperature, upwelling kind of indices, as well as biological conditions such as the prey availability. And this is the State of the Ocean report really outlined this from Dr. David Mackis's work from the Institute of Ocean Sciences, where he's looked at the west coast of Vancouver Island and looked at the shifting composition of zooplankton and how during warmer years, the warmer water copepods move up from the southern climates into our waters, and these copepods tend to be larger and energetically less good than the colder water species that are typically here. So it's like eating when the warm water years hit and these warm water copepods come up, it's like eating a hamburger and French fries and a Coke versus eating in normal cold years a salad with a well-balanced meal. So the fish in the warm years are getting this poor food quality. And David Mackis has been tracking this on the west coast of Vancouver Island, so we included that as well. There isn't as much copepod information in the Strait of Georgia. I know that they're working on compiling piece together time series from a bunch of different sources, and but for the purpose of this, all we had was the west coast of Vancouver Island. So we color-coded again, similar to the forecast table, where we were trying to rank these in terms of whether these environmental conditions were average, below average, or above average. So green, good for salmon survival, red, poor, and yellow is kind of average for salmon survival. And I guess what I want to point out about this graph is that there's a lot of variability in terms of survival and how it actually links up, even with these broad different indices, and how the top line is Chilco marine survival, just as an indices of overall marine survival for Fraser sockeye. That was the one indicator stock I mentioned earlier. In 2005, all the indicators, and if you read the State of the Ocean report the DFO publishes, compiled from all these scientists, ocean conditions were generally poor for survival conditions, and 2007 was actually a poor year for marine survival for Chilco, as well as for productivity amongst stocks. So we kind of thought we were on to a somewhat right track, because indicators were lining up somewhat, telling us things were bad in 2005, and they really were bad. 2006, we started seeing a transition. When we went to the State of the Ocean meeting, we've got all this information that ocean conditions were improving. We're seeing more transitional. However, we were still recommending more conservative probability levels on the forecast, given it being transitional. It's unclear which indices are driving it, but we were transitioning. We did also see in 2006 an improvement in Chilco marine survival, so we were seeing this turnaround in 2006 of improving marine survival conditions. Then we went to the 2007 State of the Ocean, and for most indicators now it was intermediate in terms of some of the conditions, or really good. Of course, there's always exceptions where certain things retrospectively you can look back and go, oh, that was saying things weren't great. But when you look at it holistically, the general message from that meeting was things were looking pretty good in 2007. So we were thinking going into the 2009 return year that things were good. There are so a lot of this is extracted from the State of the Ocean report. There's other individuals, as I'd mentioned earlier, the value of forecasting is playing around with exploring different hypotheses for what is driving survival for Fraser sockeye. We do that within our own forecasting process. It's part of that exploration. But Dick Beamish, Dr. Beamish, as well as Skip McKinnell, Dr. Jim Irvin, all these other scientists are also exploring different hypotheses for survival. And at the time of the 2008-9 forecast, I know Dr. Beamish's work was in very preliminary stages. He was focused on September catch per unit effort when you look at the State of the Ocean report, and he recognized in later State of the Ocean reports that those were September CPUE, after he did some DNA analysis, realized that all those fish that he was sampling in September were Harrison sockeye, which Harrison have so many unique things about them. They're doing very unique things in terms of their life history, in terms of their survival. They're improving in survival, whereas all the other stocks are going down. So at the time of the 2009 forecast, I know certain hypotheses are, pieces of hypothesis development were in the preliminary stages. So for certain scientists such as Dick Beamish, his stuff was very early, and it wasn't until later on that he started getting the DNA back and realizing that he wasn't even using the right time period from his surveys. He was using September CPUE to try to forecast total sockeye. So he made a statement in the State of the Ocean report from the 2006 or 7 State of the Ocean report about conditions and what they expected, but it was a work in progress and it's being developed. So we did explore his work amongst all the other environmental variables that were being considered, but recognized that it was a work in progress. It hadn't actually produced the right forecast for 2008, so it wasn't a hypothesis that we were going to move forward on and place a great weight of evidence on in moving into 2009, when the bulk of the evidence suggested that indicators were good. And all these scientists are working and developing their hypotheses further, and it's a work in progress. But we definitely, every year, explore environmental indicators quite extensively.
I have no other questions for Ms. Grant, but I know that Canada has some questions. Should we move to Canada, or did you want to follow up on anything with the witness before we do that?
No, that's fine. Thank you, Ms. Baker. Thank you.
Mitchell Taylor, Mr. Commissioner. In my questions for Mr. Lund's benefit, I expect to refer only to Exhibit 340, which is the 209 forecast, and Exhibit PPR 5, which is the Harvest Management Practice and Policy paper. Ms. Grant, in answering the question that the Commissioner posed to you about mid-morning today, you referred to, I think I heard you say, 95% of the returns in a given year would be the 4-year-olds, and I think I heard you say at another point 85%, and then at one point you referred to 20% 5-year-olds in a given year. Can you just explain or elaborate on, is there a number, or is there a range, or which of those numbers would be the 4 versus 5 ratio on average?
Yes, for clarification, there is a range. So I don't have the exact range in front of me, but it would be pretty small, and it probably would range from 80 to 95% or 99% even. So the key message I was trying to get across was more, they make up, the 4-year-old component makes up a significant component of the run. I was not recollecting the same every time I mentioned it, but it was, what I was trying to get across was that it makes up a range from probably what I just described, a pretty large component, with exceptions. For example, pit sockeye is one exception where the 5-year-olds make up a much larger component than that. But I was trying to describe just a general range and wasn't being consistent.
All right, thank you. And the large percentage you're referring to is the 4 years, I take it?
That's correct.
In that same area of your evidence, or picking up on that, will DFO know, with regard to the 2010 returns, what percentage or roughly what percentage were 5-year-olds, or the ratio between 4 and 5?
DFO does have preliminary return results for Fraser's sockeye by stock. I can't speak to specifics. I wouldn't recollect it all perfectly, but there were no surprises in the returns in terms of age composition. So we didn't see in the 2010 returns any anomalies in regards to having a greater than normal age 5 proportion in the return distribution.
You also mentioned in that same area of your evidence pink years. And just for clarity, can you explain what years are pink return years and what years are pink out-migration years?
Pink return years are odd years for the Fraser system.
And outgoing?
And it would be even years for outgoing. So they would spawn and the fry would emerge from the gravel and they would migrate to the ocean in even years.
Thank you. Now, is there something you can point to link or tie the 19 stocks that are forecasted as against the conservation units that exist for Fraser sockeye?
Yes, in the 2009 report,
The forecast report?
the forecast report, I believe,
Which is
There's-
Exhibit 340
Table 1 and 2 in that report.
on page 6 and 7. And if
So-
you could just explain what this is telling you or how you see a relation or what is the tie.
Okay, Holtby and Saruna in 2007 published a first cut at the conservation units for all Pacific region salmonid stocks. And in this table, in the forecast table, in light of the wild salmon policy and moving forward into the future, we wanted to align the stocks that we forecast, so the 19 forecasted stocks, including the miscellaneous stocks that we forecast, and link them to the CUs from the Holtby and Saruna paper. So what we did in the second column of Table 1 is list next to every stock the numbers that are associated with the conservation units that are listed on Table 2. So we'll use Bowron for an example, the first stock in early summer. Bowron has in the CU list in Table 1 the number 3, and then when you go to Table 2, that Bowron stock is associated with the Bowron Early Summer Conservation Unit. So we're just lining up what stocks go with what conservation units, and in some cases you can see, like for the example of Bowron, that the stock lines up exactly with the conservation unit. So they're the same thing. They're looking at the same thing. Other ones, such as fennel and raft, are North Thompson stocks, and fennel and raft together add up to the Kamloops Early Summer Conservation Unit. So that's an example of where two different stocks in our forecast table are equivalent to one CU. So it's a little different. And then there's other CUs, such as, I will just pick another one, like Chilco, for example, in the summer run. So the first stock in the summer run timing group on Table 1, they include CUs 13 and 14. And so they're an example of a CU that, a stock in the forecast table that's associated with two CUs. So they include Chilco Early Summer and Chilco Summer as the conservation units. So it's just to summarize, there are some cases where there's perfect correlation between the stock and the conservation unit, other cases where two stocks amount to one CU, and other cases where two CUs equal one stock.
All right. Is that sort of information or tie in the 2010 forecast?
We don't include it in the 2010 forecast. There is a work in progress paper that's being published, and we're in the process of working through conservation units, and So we haven't included an update in the 2010 forecast.
Do you know if it'll be in the 2011?
2011 forecast, that's what I meant.
It's not in it?
No.
All right. Now, I'd like to ask you a couple of questions about a document that's referred to as a policy and practice report. It's policy and practice report number 5. And that's coming up on the screen. And if we go to page 81 of that document, and specifically paragraph 212, I have a question for you. You'll see under A, it says, well, I'll read all of it, but key to preseason planning are A, preseason forecast for each run timing aggregate. Do you have anything that you want to say about that statement?
Sorry, Mitch, can you repeat what are you on to?
Number A there.
Oh, A, yes, okay.
Is that accurate,
Yes.
or is there anything that you want to say?
The only clarification we would, or I would ask, is that for preseason planning, it would be clarification on whether these I would assume that preseason forecasts would include the abundance forecasts that I'm involved with, as well as the diversion and run timing forecasts that were responsibility of another DFO employee, but those 3 kinds of forecasts would be included. So it might be just requiring clarification on whether that wording encompasses the 3 different kinds of preseason forecasts.
So that would be diversion, run timing, and abundance.
Yes.
Then if you go to a couple of page over to paragraph 225, and I'll give you a moment to read it if you like. But if you could have a look at that and tell the Commissioner whether you have anything to say about what's stated in that paragraph.
This paragraph would, if reworded, would capture the changes in methodology more appropriately. As written, it's a little unclear that the changes made to the methodology don't apply to all 3 productivity scenarios. So I would recommend a change that would involve saying something like, for the 2010 forecast, it included 3, so you would pull out the presentation of the forecast as 3 different productivity-based results in 3 different tables. Would probably change the wording of that to the presentation of 3 different forecast tables using 3 different assumptions of sockeye productivity, and not turn that into a number 2, but switch it into significant changes include that statement as I'd worded it, and then a period, and then there were the long-term average productivity table, the first case, was identical to methodology we've used in the past. Changes were made to the methodology specifically for the recent productivity case 2 and productivity like the 2005 brood year case 3. So those were the only 2 cases where methodological changes were made.
And
So
that's all as you described earlier this morning.
It is, and so it's just a little more complicated than as it is, or not complicated, but it just needs to be switched around so that this sounds like changes were made to every forecast scenario.
All right. Okay. Anything else about that paragraph that you want to pick up on?
Well, I would be specific that the retrospective analysis conducted over the last 8 years was specific to the recent productivity forecast table. And the same with the use of models like the Coleman filter, and I would say use of models like the Coleman filter Ricker model, if we're using an example. And again, that's specific to the recent productivity forecast table. And for both the recent productivity forecast table and the productivity like 2005, the last point applies to both of those.
All right. Can you briefly describe the collaboration that accompanies the work that you do in forecasting?
Yes. We, over the years, have done significant collaboration with our colleagues within the Department of Fisheries and Oceans. So, for example, Mr. Alcass is foundational to the forecasting process, and we work as a team in collaboration with other people with similar expertise within the department. So we would collaborate significantly with individuals like Alcass, who has a legacy of forecasting and is foundational to the forecasting process. We would also engage other individuals within the department who have expertise. We collaborate also outside of the department with individuals who have expertise in forecasting and Fraser sockeye. So, for example, the Pacific Salmon Commission has been extremely helpful in the forecasting process, from Mike LaPointe's input over the years on just his incredible understanding of the animal and the brood year escapements, returns. He understands the data. He always is extremely helpful, and we collaborate extensively throughout the forecasting process with Mike LaPointe. And also Dr. Catherine McKelson's, we have also collaborated extensively with. She's a Bayesian statistical expert and has provided us with lots of advice and assistance in the forecasting approach. And she is a lead author on the 2010 forecast paper and assisted with the 2009 forecast. We've also engaged Dr. Randall Peterman with forecasting approaches, trying to stay on the cutting edge of models that are available. So I worked with Dr. Randall Peterman, taking one of his courses on risk assessment, as well as working with him directly on the forecasts. We did a lot of collaboration when it came to using the Kalman filter Ricker model, which was one of his forecasts that looks at product shifts in productivity over time versus just looking at average productivity. So we've collaborated with him there. Dr. Randall Peterman was also a reviewer of our 2010 forecast paper, and agreed with the methodology and felt that we were using cutting edge methodology that's available in the field. We also, the collaborations go on and on, because I've already talked about the environmental conditions where we've collaborated extensively or engaged scientists on ocean conditions, freshwater conditions, as well as our operational programs. Within my division in stock assessment, I'm the analytical arm, whereas we have a sockeye operational group as well. And we would engage extensively on them, on the data, issues like that. So there's a lot of collaboration when it comes to the forecast.
All right, thank you. Now, bearing in mind the uncertainties and variables in all of what you've said in your evidence so far, can you say in your assessment how good is the forecasting that's done for Fraser sockeye using the processes and methodology you've described?
Relative, in the world of forecasting, I think through, again, Dr. Randall Peterman's reviews and others reviewing our methodology, our methodology that we use for Fraser sockeye is it's using the best available tools that are available to us for the world of for sockeye forecasting salmonid stocks. Not only that, we're even on the cutting edge by incorporating models like the Kalman filter Ricker model that have been recently introduced by Dr. Peterman, by incorporating time varying productivity parameters within our models. So I think it would be generally accepted that the modeling approaches we've used, and Randall Peterman would agree based on his comments at the review of our 2010 research document, that our methodology used is very good, like it's at the cutting edge of what is available in the scientific community.
All right, thank you. Is there anything else by way of information or points that you think are important for you to make about forecasting for the commissioner or to the commissioner? other than beyond what you've already testified to?
I think we've covered the key points. There's
All right.
nothing.
Thank you. Those are my questions.
Thank you, Mr. Commissioner. I believe the next up is Mr. Leadham for the Conservation Coalition.
Leadham and Che appearing as counsel for the Conservation Coalition. I want to begin by thanking you, Ms. Grant, because before you gave your evidence, a lot of forecasting was incomprehensible to me, and I gained some understanding. I can't pretend that I understand Bayesian probabilities, nor do I think I ever will, but at least I have some appreciation for what it is that you do, so I thank you for coming. I want to reflect on the wild salmon policy and some of the work that you've done. You alluded to a paper that's presently in the works, and I wonder if we can just take a quick look at Exhibit 184, Mr. Lund, please. Are you the same SCH Grant as main author on this paper?
Yes.
And my understanding is that this particular paper, which deals with benchmarks for Fraser River sockeye conservation units, was reviewed last fall, was it?
It was reviewed in the spring of this past year, I believe. Yeah, this past spring.
Okay. It went through the CSAP process, did it?
Yes, it went through the CSAP. I'm just switching gears mentally now from forecasting.
All right. I'll give you a moment to reflect
Yeah,
on it,
I'm
because
just
my
thinking-
information is that this went through the CSAP process sometime in November of 2010.
Yeah, I'm mind blanking on when it went through the CSAP process, but it did go through the formal CSAP process, and it's a research document similar to the 2010 forecast paper in the type of document that it is.
And my understanding is that the paper is presently under review. I just wanted to get an updated status on it.
Yes, this draft, this exhibit draft that you have is prior to the CSAP process, so the science advice process within DFO, and it was a 2-day CSAP process. So this paper was what all the formal reviewers, that included again Dr. Randall Peterman, Mr. Mike Staley, and a third reviewer as well. And so there was 3 formal reviewers, as well as the CSAP's Salmon Subcommittee, which included Dr. Carl Walters being present, Dr. Catherine McKelsons, and a room full of technical experts. So this paper is what all those reviewers, the formal ones and the people present in the room, would have seen. But coming out of that meeting are recommendations from the formal reviewers as well as from the CSAP process, and it does not encapsulate any of that at this point in time. So there will be changes made to the methodology, our approaches, and this will be published in the spring of this year.
All right, that answers my question. I just simply wanted an update on it.
Okay.
Earlier today, you gave evidence about the forecasting and about incorporating environmental variables within your forecasting. And I think you listed a couple of them. One was sea surface temperature. Another one was Fraser River flow. I was wondering if you would also give some consideration to incorporating water temperature in the Fraser as an environmental variable in forecasting. And the reason I asked that is that last week we heard from Mr. Lapointe, who gave evidence and highlighted that environmental variable as a key factor in survivability of the fish as they're migrating upstream. Would that be something that you would want to consider as an environmental variable? Can you factor that into your modeling exercises?
Yes, we could factor that variable into the modeling exercises. And one of the challenges with incorporating just that single variable is that when you consider the life history of Fraser sockeye, in fact, a lot of the mortality, the bulk of the mortality occurs probably from the egg stage. When you consider billions of eggs are laid, from the time they emerge from the gravel, a lot of mortality occurs in that stage. A lot of mortality is thought to occur. One of the key hypotheses for survival of salmonids is that, or fish in general, is generally they're most vulnerable when they're smallest and youngest, so they're more vulnerable to mortality mechanisms like predation and starvation. And it's also thought, so in the freshwater environment, it would be a lot of mortality occurring early on in the freshwater environment, as well as that transition into the marine environment. It's thought that the bulk of the mortality, this is a hypothesis, that a lot of the mortality would occur early on, because when they hit the marine environment, they're their smallest, and they're more vulnerable to predation because they're not able to swim as fast. The bigger you are, the faster you can swim. Also, to tolerate periods of less food availability. If you're bigger, you have greater energy stores. So usually it's thought that early on, when you first hit the ocean, you're most vulnerable to mortality. So part of the downstream migration, there could be considerable mortality as they're migrating down as juveniles, as well as when they first hit the ocean in the Strait of Georgia, early on along their migration along the continental shelf. So getting to your question, it's thought that most of the mortality, and when we cue in on mortality mechanisms and environmental variables, we're cued in on variables that would be drivers of that early marine ocean entry or downstream migration elements. The variable that you're describing, definitely we know through work of, you're going to hear from David Patterson and others working on environmental conditions and how they influence returning salmon and influence mortality of the returning salmon. They can play a big role in mortality, but in the grand scheme of the sockeye life cycle, it's generally thought that it's this early ocean entry period or juvenile period in the freshwater that's driving recruitment variation. So it's a part of the puzzle, but using it again as a single environmental variable probably would explain very little of the total variability in salmon survival.
I want to end up by contrasting the 2009 return and the 2010 return, because those were the two returns that you spoke most in terms of your evidence. Do I have it right that the 2010 return you could describe as being a bonanza, but mostly due to the late Shuswap, the great runs of the late Shuswap that we saw last year? Is that right?
Yes, I would characterize it that I don't have, again, all the preliminary data in front of me, and it's not an exhibit, and it is preliminary, but you are correct that preliminary returns are suggesting that the drivers of the abundance in the 2010 returns were the late Shuswap, which is comprised, like the big part of that run is the Adams run, as well as even the early summers, the Scotch Seymour component, which are Shuswap rearing fish as well. So it appeared that the Shuswap rearing fish, both in the early summertime component and the late time component, did pretty well. Of course, it was late Shuswap that was the bulk of the abundance in 2010, and it was also the stock that we haven't seen persistent declines in productivity on their time series. Unlike other stocks that have been declining, late Shuswap has been kind of stable in terms of its productivity. So in terms of our recent productivity forecast, it actually wasn't too different for late Shuswap than the long-term average, because productivity hasn't systematically declined for late Shuswap. And the having said that, even so, late Shuswap, when you place it on the map of the long-term average forecast table, it's still falling out at the high end of the probability distribution. So it's, on top of it not having exhibited any declines in 2010 in productivity, it appears to have exhibited increased productivity in the 2010 returns. So no doubt that late Shuswap was driving those returns.
But that same abundance pattern you did not see emerge with other stocks or other conservation units. I mean, those conservation units, and I know the results are still preliminary, but those conservation units such as Cultus and some of the other conservation units, they still remain flat or in decline. Is that right?
No, that isn't correct. Again, I don't have all the data in front of me, but I know that for a lot of the other stocks in 2010, there's a few that if you place them on the long-term average productivity, they did better than recent productivities. So we had put that forward as the most greatest weight of evidence was the recent productivity second case, and a lot of the stocks we switched over. If you want to compare them, you switch over to how they compare to the long-term time series. And Lake Shuswap was extremely on the high end of the probability distribution, so it suggests their productivity is really good. But a lot of the other ones were still showing average, above average productivities. And then there was several showing below average. So Early Stewart is one example of one that was, I believe, the return was in the 100,000 range, so it was slightly below the long-term average. So there was nuances amongst the stocks in terms of how they were doing. Cultus was one that actually didn't do, it did okay this year. There was a good return. I know back to the fence we were seeing something like 10,000 fish. So it was on, it wasn't, productivity was not as bad as the recent productivity we've seen even for Cultus.
But going now to 2009, that was, as you say, an anomaly because we saw most of the stocks, with the exception of the Harrison and potentially some of the Lake Shuswap, showing a very marked decline. Is that fair?
Yes, in 2009 we saw a more consistent signal of below average productivity across all stocks except for Harrison in that return year. In the 2009 return year, Harrison was one of the exceptions. And of course there's variability in terms of whether it was the lowest. For most stocks it was amongst the lowest productivity we'd seen on the time series, but there was variation amongst the stocks.
Thank you. Those are my questions.
Okay.
Mr. Commissioner, I only have a few questions of this witness. I share the gratitude that was expressed earlier by Mr. Leadham. Could we turn to Exhibit 340? And I just want to pick up on the transition from the way the forecasting has been done over the 19 stocks and the way we're moving into the conservation units. And I noticed from the evidence that you gave, Table 1 on page 6 of the actual document, I noticed when I looked at the comparison of the 19 stocks and then I looked at the conservation units that the predominant aggregate that, bear with me as I use layman's terms, that could be disaggregated is the summer runs. Is that a fair observation? It looks like the group of summer runs are the ones that have the most groupings of the conservation units. Have I read that right?
Yes, they would comprise, based on what you're saying, that is correct. They have multiple conservation units within them, more so, like that run timing group would have more multiple conservation units within an individual stock than generally speaking, than the other run timing groups.
And so the work in terms of moving from the 19 stocks into the conservation units, whatever number we end up with, could well be served to start focusing on the summer runs. If we had to prioritize where we could get the best bang for our buck in terms of disaggregation, it was getting more information about the conservation units, beginning to gather more information over time, and in terms of conservation units, that if we began to focus particularly in the aggregate of the summer, that would be a useful thing?
I think for clarification, just because the conservation units are aggregated with a particular stock doesn't mean we don't have, oh, maybe that's what you do mean, disaggregating the recruitment time series.
That's right.
Well, I know a holistic, or like an answer to your question is that is definitely, from my understanding, what we're working towards. The Pacific Salmon Commission is responsible for creating the stock recruit time series, pulling together all the data from DFO's escapement work as well as catch work. And I know that that's something that the Pacific Salmon Commission was working towards, the possibility of being able to, as you put it, disaggregate the stock recruit time series so that you could look at individual conservation units. But that's a work in progress.
Perhaps my next question could just flow from that, because I am curious on how we can begin to do the work of moving from the 19 stocks into the conservation units. And I'm wondering if I've heard your evidence correctly today, is that we could be, you could begin to develop forecasting models for those conservation units. You're lacking the long-term numbers for that. So you're lacking long-term escapement numbers for some of those conservation units. But you could begin to develop relatively soon the more recent numbers on those conservation units. Is that correct?
I would characterize that somewhat differently. The wild salmon policy, I call it the wild salmon policy toolkit that Holt et al. Had published in 2009, I believe, describes a number of tools that can be used for wild salmon policy stock status work. And within that toolkit were things like trends over time. So escapement trends over time as a tool for assessing status. And for a lot of these conservation units, so for example, Lake Stewart has Tacla Trembleur Summer and Stewart Summer as two separate CUs incorporated into it. I'm just going to cross-check this. Yeah, so it's 15, 16, Stewart Summer and Tacla Trembleur Summer. And our escapement time series does disaggregate, like we enumerate our spawning ground assessments so that we have separate estimates for Tacla Trembleur and the Stewart Summer. So those two CUs, we could do stock status work on the CUs independently using different metrics.
So you could actually provide the forecasting on those two already?
When I'm saying the wild salmon policy tools,
not the benchmarks on it. So let's stick to this. If I'm confusing things, please let me know. But when it comes to just the forecasting work that you're doing, do you have the forecasting tools to give us forecasts for both of the conservation units in the Lake Stewarts?
Well, yeah. On one hand, we would. For some of the CUs, because we could use what we're calling non-parametric models. So you could use, because we can split out for Lake Stewart as an example, the brood year escapements into the two conservation units. You could use the two different brood year escapements for the two different conservation units multiplied by recruits per spawner, time series average, or you could look at variants of that kind of model, because we can separate for a few of these CUs, the escapement time series. We wouldn't necessarily at this exact point in time be able to use all the biological models depending on where we're at for separating out the recruitment time series. So where our spawning ground assessments do provide fine enough resolution to separate into individual CUs, it's our recruitment information, which is the catch component of escapement plus catch. So the escapement part we could partition, but the recruitment part, which is partitioning catch into the separate CUs, would be an ongoing, is part of an ongoing process, and it hasn't been, I'm not sure where we're at with that, but it's not something at present we'd be able to do. It's a work in progress. But there would be certain models we could use by CU.
I somewhat think it would be unfair for me to ask you which of these you could do. Which could you do a forecasting model right now?
Well, the challenge with answering that question would be that this is this CU list is from Hopi and Saruna's 2007 paper, and we are in the process of updating that current list. So these CUs wouldn't necessarily be the final CUs. That's a work in progress as well that we'd be finalizing with the April report. So it would have to probably wait until we had all the final CUs to put into that table, because there'd be a lot of, not a lot, but there'd be changes to what you see here. So to go through one by one could be, it might be misleading given that the conservation unit isn't finalized.
Okay, I'll move on and not press that point with you at this time. I'm curious, the chart that you call the report card, chart table 5 of this same document at page 16, I don't see it in the 2010.
Oh.
Is there a reason for that? Did I miss it?
No, you didn't miss it. The reason we didn't include it in 2010, we're still tracking state of the ocean environmental conditions, staying in the loop on what's going on environmentally. But given the indicators that we had selected had not captured the survival conditions that we saw in 2010, being that, or no, I should go back to the 2009 return year, because this suite of environmental variables had indicated to us that the environmental conditions were good. So if you look at that last circled column on this chart, that was the 2009 returns for most of the sockeye that returned in 2009 as 4-year-olds. All those environmental indicators that we had selected and from the State of the Ocean report had broadly said that, or indicated that ocean conditions were good. And in fact, the returns in 2009, as we all know, were amongst the lowest productivity on record. So whether these aren't capturing either the environmental conditions in the ocean or we're missing something in the freshwater environment early on, we felt it wasn't informative given it was disconnected with what actually occurred in 2009. So we decided not to publish again in 2010 the state of the, this information, and instead reference State of the Ocean reports, but not specifically provide this given it disconnected for 2009.
Okay, that's helpful. Thank you. I take it from the evidence you've provided us so far that it's your thinking that taking any one particular environmental variable is not helpful in forecasting, and that so far it's not helpful. I want to turn your mind to the issue of cumulative impacts, which is sort of the opposite way of saying that there's a lot of impacts along the way. A lot of impacts in addition to global temperatures, which is what I take to be the primary indicators that are being used right now. Temperature for water, or water temperature, or water flow as a result of ice pack melting. So there are a lot of other cumulative impacts. I'll just take urbanization at the mouth of the river, for example. Are there models that are being developed or considered either in British Columbia or in the world that you're aware of that would help us to begin to include in any of the forecasting, anything that we're doing, these cumulative impacts that salmon are responsive to?
I'm sure there are. I'm not necessarily.
You're not aware of any of the cumulative impact?
I can't speak to any specifically. So no.
Okay.
Yeah.
Hoping you could turn our minds to certain ones that might be helpful to us. All right, then the last area of questions I have is just around the whole issue of communication and uncertainty. And I thought your evidence this morning to be particularly helpful, especially the expression a lot of people focus or fixate on a number. Mm-hmm. And so I have, given the broad range of users of things like the CSAS paper, the public, the managers, and the harvesters, do you have any recommendations on how we can communicate better the purpose of forecasting and what you're doing here? and it's a twofold question, and the implications of those uncertainties to those that are reading them.
I think communicating uncertainty and communicating the forecast is definitely something we're constantly working on and playing around with. So it's one of the reasons why I think in the 2010 forecast started presenting in the 3 different cases in those horizontal bars that were presented on page 41 on the 2010 research document by Grant et al.
Yes, I remember those.
Okay.
Yes, so that's one of your
So
ways.
we are playing around with different ways to communicate the uncertainty in the forecast, and that table, as we were walking through, was communicating both uncertainty in the stochastic random uncertainty and observation error, process error model, that kind of thing in the forecast distribution, as well as presenting uncertainty in regards to our assumptions about survival of salmon, whether for Fraser sockeye we expected 2009 to repeat itself or we expected long-term average. So we were playing around with different tools for communicating this complex sort of uncertainty in a simple form. And the idea is that once you're walked through it once, the next time you see it, you'll know right away what that's communicating. So it's the hard step is just walking through and explaining it. But once you have it, you get a grasp of what you're communicating. I know communication really interests myself, especially in the forecasting world. And it's definitely a challenge in communicating complex information, as I was describing earlier today, why the forecasts are beneficial, and the miscommunication of the forecasts being a single number and not a probability distribution, and what these forecasts are really telling us, rather than the sort of misdirection on the forecast being wrong. Instead, they're actually telling us, flipping it around and saying, no, the forecasts are actually telling us that what happened in 2009 was at the extremes of our range of experience. So I don't know, I don't have the answers. I know that we're working on it. I think just getting out there and being proactive in communicating it more might be helpful. I know we communicate it in management planning, and maybe it gets simplified somewhat. Not simplified there, but part of the miscommunication can be that we're putting certain probability levels into tables, and people then when it gets out to the public, they see the single number and they start to forget that there's a probability distribution associated with it. So maybe there's improvements in how we're communicating in season from the department and from the Pacific Salmon Commission, because we all release news releases throughout the season. I think just being more proactive and getting out there and having even, communicating like this to people and having people understand the complexity. But I think it's a bigger question for the department also to tackle in terms of how communication can be improved.
The thing you're doing is forecasting a range of probabilities as distinct from providing forecasting of actual run sizes.
Well, we're forecasting, it's kind of like a combination maybe of those. We're presenting, based on our historical understanding of the Fraser sockeye populations, we're forecasting the probabilities associated with different run sizes. So based on historically what we've seen. So which run sizes would be most probable given what we've seen historically, and which are becoming less and less probable. So moving from 10% probability level, which is a 1 in 10 chance of seeing a run size, up to a 90% probability. So so it's kind of a combination of what you're saying.
Okay, one last question, which is, I heard the complexity you have around communicating the uncertainties in the forecasting. I'm curious, what efforts do you make as someone who's responsible for generating these forecasts to communicate the implications of those uncertainties to the managers, for example, the Fraser panel? Or is that work that you do, or do you rely on others to do it, or how does that get done?
It would be a combination of myself. I would be generally the presenter of the Fraser forecast and communicating the uncertainty for the Fraser sockeye forecasts at Pacific Panel Treaty meetings, so PST meetings. So annually, when we're in the pre-season planning mode, generally in February, sometimes the January meetings, which is postseason. Generally we'd have the forecast done by them then. I would be responsible for presenting at the panel meetings. We also have integrated management team meetings where I might present at. Others might present the forecast as well in different forums. Because I can't be everywhere at once, sometimes it's tasked to people who understand the forecasting methodology and who will present at other forums. So it's a combination of myself and colleagues who are also technical experts and understand the complexity of the data.
Canada had any re-examination? But
None.
no, neither do I.
I just had one quick, I think you have a binder in front of you, Ms. Grant?
Yeah. Yes.
Just to clarify for me, tab 2, at least in my binder, is the CSAS document. Is that correct?
For 2006?
Yes.
Yes.
I understood you to say that this document is not posted on the DFO website.
This document would be posted.
It is posted.
It is.
And then the tab 3 is the, I think that's Exhibit 340, I'm not certain, but that's the preseason run size forecast for Fraser River sockeye in 2009.
Yes.
That's also posted?
Yes.
So do I take it then that tabs 4 and 5 similarly will be posted?
Yes.
And do you have a counterpart at the Pacific Salmon Commission, or do you fulfill the role of advising on forecasting for both the DFO and the Pacific Salmon Commission?
The forecasting responsibility for abundance forecasting for Fraser sockeye is DFO's responsibility. So we are ultimately responsible for producing it, so I would be the lead on the production of the Fraser sockeye forecast, but we collaborate and work with technical experts within the department and outside, which is why we have Dr. Catherine McKelson's on the 2010 forecast as an author, because we've collaborated outside the department, but the delivery would be on the department for production of that forecast. But because we engage the broader scientific community, it can engage anyone out there who has the technical expertise that we want to engage. Similar to any scientific paper that you write in the global community, you would engage colleagues and counterparts with expertise in other areas. So, but the ultimate responsibility lies within the department.
But all of the modeling work that you've been talking about all takes place within the DFO, not within the Pacific Salmon Commission.
As I mentioned, because we collaborate with the Pacific Salmon Commission, there would definitely be modeling done by the Pacific Salmon Commission in working with us collaboratively to assist with the forecasts. So there would be modeling done by the Pacific Salmon Commission to assist with the forecast in a collaborative way. I mean, we're working together.
But are there documents similar to the ones that you've got in your binder from the Pacific Salmon Commission?
No. They just collaborate with us on our documents because we're the ones responsible for it. So we're working together on this document.
I see. Okay.
Right.
Thank you very much.
We do have hopefully our next two witnesses here, so perhaps we can take a shorter afternoon break. I'd like to be able to get some substance out of the way with them this afternoon. So,
All right. Thank you.
Hearing will now recess for 10 minutes.
Thank you. Oh. 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 oh, 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 oh.